Good morning, students. In the last class, we are discussing the rules of algebra of sets. Okay, and during that discussion, perhaps two rules were discussed. First was idempotent law, and second was idempotent law, and second was law of identity. No. Now we will discuss some more rules. First was idempotent laws, and second was law of identity. No. Third we will discuss commutative property. Commutative property. Okay. Commutative property in previous classes, and I hope perhaps from class 6, 7 or more earlier. No, we do the commutative property of addition and multiplication. For example, 2 plus 3 equal to 3 plus 2. It is the commutative property of addition. In the same way, 2 into 3 equal to 3 into 2. It is the commutative property of multiplication. We always here the operation is addition and multiplication, and the elements are numbers. No, in set theory, such type of rule is also applied. In set, we take two sets A and B. In place of two numbers, we take two sets, and the operation is, suppose, union. A union B equal to B union A. Commute means interchange. Interchange in Hindi, it has very appropriate word, binimay niyam. Kram binimay niyam. Kram means order. You can see first is A, second is B. Binimay means exchange. See here, in the first place A, second place is B, and here on the first place is B, and in the second place is A. Therefore, it is called the commute. Commute means to interchange. This type. Suppose this is the head, two are hands. If we commute, this will be the commutation. Similarly, you can see here A union B equal to B union A. The same rule can be applied for intersection. A intersection B equal to B intersection A. It is the commutative property of union, and it is commutative property of intersection. No, and out of these two rules, I will prove one, and the next one will be left for you. See, number A. In the previous discussion, what I had told, whenever we want two sets equal, we first show that this set is the subset of that, and in the next part, we show that part is the subset of this. Okay, this is the way. And to show the subset, what we had discussed, we take any element of this set and we show that that element belongs to that set. Also, some element will be taken from that set and then we will show that element belongs to this set. Therefore, in this way, we let X belongs to A union B. This implies X belongs to A. And for union, what I had told? I had told you, for union we use the word or X belongs to B. Okay? This implies X belongs to, this can be written in this way also. There will be no change in the concept. X belongs to B or X belongs to A. This implies X belongs to B union A. No. Therefore, what we had started, X we had taken from A union B, and that X came to B union A. Therefore, A union B is subset of B union A. Call it equation 1. Now, we should start from this side. But for the sake of time and for the convenience, we do not take from this side. We simply write it here, implied and implied by. This type of symbol means if we start from here, we will reach here. And we have started here and we have reached here. And we write here simply, similarly, B union A is subset of A union B. And from 1 and 2, you can see, now we write from 1 and 2, A union B equal to B union A. Okay, this was the commutative property. Now, commutative property of union. Now, this can be proved for intersection. Only in place of union you will write here intersection, and in place of or you will write there and. Here will be and, here will be and same is union will be converted to intersection, and thus you can get A intersection B equal to B intersection A. Okay, I hope this is clear. Now, the fourth property is associative law or associative property also you can say. Associative property. Associative property. This property also we have read in class 6 or 7. You might have, I try to recall you, 2 plus 3 plus 5 equal to 2 plus 3 plus 5. It is the associative property of addition. The associative word has been taken from association. You can see here 3 and 5 are associated. Association means together. Here 3 and 5 are together. And the association has changed. The association has come with 2 and 3. In the earlier 3 and 5. In the latter 2 and 3. Okay. This is the associative property of addition, and we all know it. These are very easy. And in case of multiplication, 2 into 3 into 5 equal to 2 into 3 into 5. No, it is the associative property of multiplication. Now we replace the numbers by the sets and the operations by union and intersection. For example, let A, B and C are 3 sets. Then number A union B union C equal to A union B union C. It is the associative property of union. You can mark here that A, B, C, their order is not changed, but their bracket is changed, their association is changed. It is the associative property of union, and A intersection B intersection C equal to A intersection B intersection C. It is the associative property of union, and it is the associative property of intersection. Okay. Now I will prove one. Very easy proof. In spite of that, I am doing one, and you will practice at your home. The next one. Let X belongs to A union B union C. This implies X belongs to A. Here is union, therefore we write what? Or X belongs to B union C. Okay? This implies X belongs to A, or for this we write X belongs to B or X belongs to C. Now, if we remove the bracket, there will be no change in the concept. Therefore, we can write here X belongs to A or X belongs to B or X belongs to C. No. Now, if we write the bracket for this, again the concept will not change. This implies X belongs to A or X belongs to B or X belongs to C. And for union, or what happens? Union. This implies X belongs to A union B or X belongs to C. This implies X belongs to A union B, and for this OR we will write here again union C. No, now see, we had started from A union B union C and we reached to A union B union C. Therefore, we can write what? A union B union C is subset of A union B, A union B union C. Okay? This is the first part. For the second part, what I told, according to the rule, we should start from here and we should reach here. But logically, if you write here implied and implied by, there is no change, there is no need to solve this again. Therefore, we simply write similarly, A union B union C is subset of A union B union C. And from 1 and 2, you write this equal to this. Okay? And I hope it is clear. And you can see how easy these questions. If you will honestly try, every question will be solved. Don't think that you are reading in class 11 and the mathematics of class 11 is very hard, nobody can solve. No, I do not feel like this. In spite of there are some questions which are difficult, for that you require some special time, special practice. No, and in this way, first was idempotent law, second was law of identity, third was commutative property, fourth was associative property. Fifth number, distributive property. Distributive property. No, distributive property in lower classes. You may say, sir, in every property you are saying lower classes, lower classes. No, then you can see all the basic concepts are lower classes. But it is the enlargement or it is the application of those concepts in set theory. Okay, that's why I am saying we have read in class lower classes, second grade. No, distributive property you see. For example, you might have seen this type of expression 2 into 3 plus 5. No, then what we write it? 2 into 3 plus 2 into 5. You can see 2 is distributed. 2 is distributed to 3, see here, and 2 is distributed to 5. That's why it is called distributive property. Distributive means to divide, to distribute. 2 is distributed here. And this into also is distributed. See here, into is here 1, and now it became 2 intos. No, and this into is distributed over addition. Therefore, we call it the distributive property of multiplication over addition. Okay, in lower classes, if you might have met a very good teacher, he might have expressed this law in that form. It is called the distributive property of multiplication over addition. No. Now, in the similar way, if we replace the numbers by sets and the operations by union and intersection, therefore, A union B intersection C. No, you can see here, union B intersection C. Now, A will be distributed to B and C, means A will be distributed to B, and here is intersection. A is distributed to C, and what will union will be distributed? A union B, union intersection A union C. It is called the distributive property of union over intersection. No, very easy. You can compare from that, and you can easily write this rule. The second number, it is called the distributive property of union over intersection. Now you may take here intersection, and here you may take union. Then in the similar way, A intersection B. No, union A intersection C. Okay? These are the two rules. It is called the distributive law of union over intersection. It is distributive law of intersection over union. No. Now, as the previous examples, I will solve one or I will prove one, and I will leave you for the second for you. Number A. Let X belongs to A union B intersection C. This implies X belongs to A. For union, what we write? x belongs to B intersection C. No, this implies x belongs to A or x belongs to B. Here is intersection, and for intersection what I had told to write? And x belongs to C. No, now you can see here x belongs to A or B and C, means x belongs to B and C both. Therefore, if we expand this, it will have the sense x will belong to A or x will belong to B, and x belongs to A, x belongs to A or x belongs to C. Okay, you can see here x belongs to A or x belongs to A or, and x belongs to B and x belongs to C. X belongs to both B and C. This implies x belongs to A union B and what? X belongs to A union C. This implies x belongs to A union B for, and we write intersection A union C. So then what we find? We had started from A union B intersection C and we reached to A union B intersection A union C. This implies what? A union B intersection C is subset of A union B intersection A union C. Call it one? No. Similarly, right here implied and implied by? No. Similarly, right from that side, A union B intersection A union C is subset of A union B intersection C. And right from 1 and 2, this will be equal to that. Okay. This is the distributive law of union over intersection, and it is distributive law of intersection over union. The second one is yet for you, and you will practice, and I hope you will succeed in solving or proving this theorem, because you can see these are not very tough matters, very easy matters. Only concepts are repeated, and you have to keep in mind the where union is and where is intersection. Sixth number, very important property, De Morgan's law. De Morgan's law. De Morgan was a mathematician and he had discovered this law. De Morgan's law. In this law, I will not say you that we have read in class in the previous classes. It is the new concept for class 11. It is completely related to set. It has two forms. One is A union B whole complement. We have done the complement. A complement to rest both, and the union is changed into intersection. This is the law. Means A union B whole complement. This complement will be raised to both the sets, and the union will be changed to intersection. In the same way, there is the rule for intersection. A intersection will be whole complement equal to the complement will be raised to both, and intersection will be changed to union. These are the two laws stating the De Morgan's law. I will prove one. The second one will be left for you. Number A. Let X belongs to A union B complement. Now, by the definition of complement, you know if X belongs to this, then X will not belong to A union B. No, you can see by figure. Suppose here is the universal set. Here is A and here is B. A union B complement means this portion is A union B and this portion is A union B complement. If X belongs to A union B complement, means X will not belong to A union B. Okay, it has come from the concept of complement. This implies X does not belong to A and X does not belong to B. You may say, sir, you have told that for union we write or, but you are writing here and. See here, if X does not belong to A union B, you can see X does not belong to this second region, means X neither belong to A nor belong to B. X belongs out of A and B. That's why we have used here the word and. This implies X will belong to A complement and X will belong to B complement. This implies X belongs to A complement intersection B complement. Now see here, We had started from A union B complement and we reached to A complement intersection B complement. This implies A union B complement is subset of A complement intersection B complement. Similarly, right here implied and implied by. Similarly, A complement intersection B complement is subset of A union B complement. No, and from 1 and 2, right? These are two equals. Okay. Okay, students. Tomorrow we will discuss the next things and you will practice these theorems. Okay. Thank you.